we are the BeastBots, team 4317. We are from Pittsburgh, Pennsylvania. We are competing in the Into Orbit challenge, and this is our second year competing. I'm going to explain to you our base robot. So our base robot has 2 medium motors for motorized attachments, 2 large motors for driving, 2 color sensors, and 1 gyro sensor. Our color sensors are very important because on the Into Orbit table we have very much black lines, and so it can sense the lines and align to them, and it will make it easier to solve challenges. We have a gyro sensor. It's also very important to help the robot stay going straight and helps it to navigate through missions. And our wall is very important because it's a very sturdy wall, so it can align to the walls of the table, and then it also makes it easier to solve missions.
We made this attachment to solve 2 missions. The first one is solar array. The second one is space travel. So this attachment works so the robot will move forward and it will push the solar array forward towards the other team's table, because that's how we chose for our strategy. This also lifts up the ramp so the cart can go down the ramp. So this attachment we used, it has 2 wall riders, so it can be aligned to the wall whenever it's getting pushed. Also, we cross-beamed all over it and we put in frames to make it sturdy so it wouldn't break on us during the mission. Also, we have pin to axle pieces here so that it could attach to the robot and it wouldn't go sliding whenever it was pushed. Once it's here, we'll leave it here so that we could add more carts to go down.
After we drive forward, we are in a perfect position to lower our forklift and put on the food supply and astronauts. I'll give you a quick demonstration with motor control. Lower our forklift onto the track and then back up so that the carts can go down the ramp. We use axles instead of beams here, because if we use beams, the only way would be to hook on the top. And as you can see, that is very unstable and inefficient. Whereas if we use axles to plug them into these holes, then we can just back up and it's much easier. We also use many gearing boxes on our attachment so that we can transfer power from our medium motors down to whatever we're using, like our forklift or our attachment for extraction.
This is a motorized attachment, so the motor lowers it down, and then this grip facing southward starts taking out the core samples. Then the robot hauls these core samples back to base so we can use them for future missions such as the 3D printer.
Obviously, the robot cannot move without programming, so in order to solve this set of missions, we created many different advanced my blocks like PID move forward, PID turning, and PID move backward. So PID stands for proportional integral derivative, and it can use many different sensors, but for us, we're using the gyro sensor. So the PID program uses the gyro sensor to detect the robot's current degree reading and tries to adjust it to 0, which is the degree moving straight forward.
High, low.
You can see we just we lower our forklift